Hello to everyone. Let's talk about the discriminant analysis. Please don't forget to subscribe and like it. So, linear discriminant analysis group data into categories, and as such, this technique is used for dimensionality reduction and the classification problems. So, this is composed by a discriminant function, and for more than two groups, a set of discriminant function. And this function are linear combination of independent variables. And in this way, this look like a multiple regression equation. So also discriminate data between categories in perfect manner. And the result model can be used for assignment of new cases into defined groups. We have an example of data, and this data is represented into two-dimensional space. This data consists in two classes and has been presented without any discrimination. But we can see now if we have a vector can discriminate these two categories. Here we project this data to one dimension. So now the researcher can find a vector direction that best discriminate between these two classes. So after this, we can have a means of each group, and we can have also the variance. So it's good when we maximize the distance between means and they have a smaller variance in each group. So what we say, I'm to find the most accurate data representation in a lower dimensional space spanned by the maximum variance directions. This might not work in some cases. On the other hand, discriminant analysis represents data in a lower dimension, preserving discriminatory information between classes of the data set. So the main difference is that PCA looks the most variation in the data, and LDA tries to maximize separation of known categories. So here we have an example. Imagine that the researcher needs to classify students based on their achievement. For each student enrolled, some information like test score and add accolade. At the end, the researcher can have students into groups, and we can also have the percentage of those correctly classified. New students to be enrolled can be classified based on the resulting model. The researcher can combine this information into function to determine how good the student can be discriminated between groups. Assumptions, the assumptions are the same as those for MANOVA. LDA are quite sensitive to outliers. Independent variable must be normal in each group. Variance among groups variables are the same across levels of predictors. LDA assume that the covariance are equal, while quadratic discriminant analysis may be used when the covariance are not equal. The sample are random selected, and score on one variable is assumed to be independent of scores from all other observations included. Group membership must be mutual exclusive. Cases can belong to more than one group. LDA must still be reliable when using dichotomous variables where multivariate normality is often violated. And here we have the step. First step, we formulate the problem for analysis. We estimate the discriminant function coefficients, determination of significance of discriminant function, interpretation of the results obtained, validity of the result, and when we use LDA. So there are cases when classes are well separated is better linear discriminant analysis than logistic regression, because estimate can become more unstable for logistic analysis. When n is small and the distribution of predictors are approximately normal in each class, when we have more than two response class, because it also provides lower dimensional views of data. Thank you for watching. Please don't forget to subscribe and like.